This is not unknown to anyone that NASA is involved heavily investigating the life forms in Mars. But is there any hope or any possibility of having life in Mars? Also, why searching in Mars and not in any other planet? So let's understand with evidence today what is keeping us hopeful towards the possibility of habitability in Mars. In 1996, a team of scientists in NASA's Johnson Space Flight Center announced that they discovered the evidence of microscopic fossil life in Mars. The discovery was based on some lifelike matter from a meteorite coming from Mars. The meteorite means a piece of rock that falls on Earth from space. NASA scientists took the samples from the solid interior part of the meteorite to avoid any contamination from Earth. They found orange-colored tinted carbonated globules, almost like limestone cave deposits that can be formed only in the presence of the liquid water. Upon further investigation on the globules, they found more granular level evidence of bacterial metabolism. Globules contained magnetite and iron sulfide. Forming these kind of materials require a biological origin. They probably can form without biological matter too, but that instigate a lot of curiosity and scope for further study. The idea that Mars once had life got a boost in June 2000 when some orbiter images were published showing geologically fresh erosion channels on the slopes of Martian craters. That means maybe there was water in Mars and water supports life. This photo is published in 2015. This dark strip of about a few hundred meters in length are hypothesized to be formed by flow of briny liquid water on Mars. This photo is published in 2022. Caltech researchers claimed that Mars rippled with rivers and ponds 2 billion years ago. The planet's atmosphere thinned over time. Water evaporated, leaving the frozen desert world. The shape of certain valley networks resembles the water paths, hinted that the water possibly flowed on Mars. The salt deposit was the first mineral evidence of the presence of liquid water. Another recent picture shows evenly layered rock that has a pattern, typically a lake floor sedimentary deposit not far from where flowing water entered a lake. In August 2024, some more findings came from NASA's Mars InSight lander that touched the ground of Mars back in 2018. Lander had a seismometer recorded 4 years of vibration from deep inside the red planet. After analyzing those quakes in the Mars, scientists found out that there is water deep inside the Mars surface. Top 5 kilometers is dry, but there is a zone of fractured rock 11 to 20 kilometers below the surface that is full of liquid water. Even the water deep inside the rock also should support microbial life. In July 2024, NASA Perseverance rover spotted a rock called Chiava Falls Rock, shows the signs that ancient microbial life on the red planet. The rock shows clear evidence of water, microbial life, and chemical reactions. This rock looks like a river once flowed there, dumping silt and created this fossilized delta. You can see the white veins in this picture, this calcium sulfate that precipitated out of water. Scans by a rover instrument also indicates kind of organic compounds of carbon-bearing molecules in the rock that are building blocks of life. Another intriguing part of this picture is the white spots ringed by black material that is assumed to contain iron and phosphate. On Earth, such spots can form by the reaction between organic molecules and the hematite on rusted iron. This is the 22nd rock core collected by Perseverance rover. Some of them contains carbon deposits that is capable of hosting microbial life. The next big step is to bring the rock or sedimentary samples, dust, from Mars to Earth for detailed breakdown and study to proper understanding of the form of life, what happened to them, and how the atmosphere in Mars got dissolved. The study on Mars will provide us understanding of the formation of Earth and its future as well. Also, if Mars could support life once, maybe it will be able to support life again in the future.